Greetings, folks. Welcome. The histograms that you just looked at do a great job of showing the distribution of quantitative variables. Visual inspection can give us a pretty good idea about the distribution shape, center, and spread. But we can also calculate some descriptive statistics to give us a more precise measure of these characteristics. Let's start with some statistics that describe the center of a distribution. The two most common measures of a distribution center are the mean and median. We'll look at the mean in this video, and in a different video we'll cover the median. The mean is the average value of a distribution. A population mean uses the notation mu, while x bar is used to indicate the mean of a sample. The mean is calculated by adding together the numerical values of your variable and then dividing by the number of observations. Let's say you have 4 observations for a person's age, and the values are 17, 21, 22, and 24 years old. If you add these values and divide by 4, which is the number of observations, you get a mean value of 21 years old. Here's a fancier version of the formula for calculating a sample mean. And here's a formula for calculating the mean value of a population. You'll notice a different notation for a mean, so we use x bar for the sample and mu for a population. And a sample size is shown as a lowercase n, while a population size is an uppercase N. Now let's dissect the formula for a sample mean. The summation sign, which is a big sigma, tells us we need to add something. The letter xi tells us that we're adding values of a variable, because x represents the variable. The notation at the bottom and top of the sigma sign tell us we're adding the value of the first observation, that's I equals 1, to the last observation, our sample, which is n. Again, that's the sample size. And since we have 4 observations, we can write it as summing from the first to the 4th observation of our variable. And here's how we can translate that fancy notation. It's just x1 plus x2 plus x3 plus x4 divided by 4. A feature of the mean value is that it is influenced by unusually large or small values relative to the rest of the distribution. For this reason, we say that the mean value is not resistant to outliers. Let's look at a new sample of 5 people with the following ages. You have the 17, 21, 22, and 24-year-olds, and now we've added somebody who is 71 years old. The inclusion of this last person, the 71-year-old person, increases the mean value from 21 to 31 years old. That's quite an increase. Because the mean is influenced by values that are outside the range of the rest of the observations, which is the case when histograms are skewed, we don't typically use the mean to characterize these types of distribution. However, the mean is the preferred measure of the center of a distribution when you have a symmetric shape. In a different video, I will show you how to calculate mean values in Microsoft Excel. But for right now, we'll just go through the formula that we'll be using. If you have a variable that happens to be in cells B2 to B501, this means we have 500 observations and they're in the B column of our spreadsheet. The Excel formula for calculating the mean value is equals average, then you put in a parenthesis, a B2, colon, B501, and then you close the parenthesis. And then when you hit return, you actually get the mean value of that variable that's in cells B2 to B501.